let's get started. I would like to introduce Kaizen Zone Will Sweet.
Thank you very much, William. And thank you to everyone else who is in attendance tonight or this morning, depending on where you are in the world. I am going to be giving a short presentation on passivation. So what do you need to know about passivation, and in particular, actually stainless steel passivation? On the agenda for this short presentation will be, we're going to start off with the what and the why of passivation, moving on to the how, and then finally we're going to talk about some testing methods to check effectiveness of passivation, as well as talking about some of the ASTM specs that go along with this application. So passivation, what is it? Essentially, it's the chemical treatment of stainless steel with a mild oxidant. These mild oxidants typically are some form of acid, whether that's citric acid or nitric acid. And what it does, the treatment with these acids or this mild oxidant, it allows for the formation of a protective passive film on the part's surface. And this can only happen, I'm going to say this several times tonight, but it can only happen when all contaminants are removed from the surface of the metal. The act of passivation is removing the free iron. That's essentially what passivation is doing. But you also need to have all oxide removed, all oils and greases removed, any coolants, etc. Why would you want to passivate stainless steel in the first place? Because stainless steel is already supposed to be corrosion resistant, right? Well, the key word is resistant. It is not necessarily corrosion proof. And in high reliability markets like medical or aerospace, you can't have corrosion in the parts that are leaving your building. So that's the reason to further increase the corrosion resistance per se. So this act it's to restore and enhance the chromium oxide film, the protective layer on the surface of the metal to stop corrosion from even starting. And that's passivation will allow that to happen even when you're if you happen to score your parts, if you're bleaching your parts, if there's iron to iron affinity, I'm sorry, anything like that. So it's you want this protective oxide layer to make sure there's no oxide that gets on your actual part. Moving on to the how. So I mentioned that you have to remove all contaminants from the surface of the metal. The left part of this table, the pre-clean options, that's one way you can make sure that everything is removed from the surface of the metal. There are many different ways you can do this. You can do, vacuum or vapor degreasing. You can do it with an alkaline aqueous washer. I'm going to get back to that a little bit because if you're going to clean your parts with alkaline or with any kind of alkalinity before you're going to passivate them, a rinse is highly encouraged to make sure there's no neutralization in the passivation tank. And speaking of moving to the right side of this image, it's just kind of a mock. This is what a passivation line could look like and what the many successful ones look like as well. Starting off with a passivation tank where the actual passivation is going to occur, moving on to a rinse, and then potentially even a second rinse. You can do this in immersion dip tanks or in spray washers, either way. So going a little deeper into the pre-clean step. So yes, just the standard oil removal or degreasing step, usually followed by a rinse, like I've already mentioned. You can do this with aqueous cleaning, with alkalinity. You can do it with vacuum or vapor degreasing. It is, again, I said I'm going to say this several times tonight, but it's very important to make sure that you remove all surface contaminants. And that's including rust. If there is rust on your parts coming in before they are passivated, this chromium oxide layer is it's still going to be formed in the passivation tank, but the rust is still going to be underneath that layer, and it's still going to have the opportunity to spread underneath that layer. So again, the passivation step is not designed to remove the rust. You're going to want to remove the rust beforehand. Typically, that is done with an acid as well. So just make sure you keep that in mind. The passivation step, what we're all here to learn more about. So again, once all surface contaminants are removed, soak or spray with a citric or a nitric acid product. So the picture on the right is an example of immersing the part in a citric acid product for passivation. When you're doing this and when you're designing your passivation line, make sure to keep your process parameters in mind. And by that, I mean time, temperature, concentration, and impingement energy. So essentially how long it's going to be in the passivation tank, at what temperature, how much chemical to water ratio is going to be in there. as well as the impingement energy. It's tough if you're not going to have any mechanical energy applied to these parts as well. Your process time is going to go through the roof. So that could be ultrasonics, that could be spraying, that could be turbulation, whatever you might have the capabilities to do. Continuing on, this is an example of a successful passivation set of parameters, not necessarily an average operating parameters, but I mean 5 minutes of parts being immersed in the citric acid solution between 140 to 160 degrees Fahrenheit, 50% concentration. So again, that's 50% chemical and 50% water. Impingement energy, this one in particular has turbulation and ultrasonics, not at the same time, but they incorporate both of them within the 5 minutes. Depending on your floor space, all your different process constraints, further optimization is highly encouraged. So the rinse step or the rinse steps. Clean water rinses are recommended between each step. I've already touched on, especially if you're using any alkalinity in your pre-wash. If you make sure to rinse off your parts after that pre-wash, after that pre-clean step, to make sure that you're not carrying over any alkalinity into your acid bath. That's just going to, you're not going to have very long bath life. The alkalinity and the acid, whenever they're mixed together, they start to neutralize, and then you're not able to do the things that acid are designed to do. Further, even after the acid bath, you're going to want to rinse off the acid from the surface of the metal. That way they can be handled more safely. After passivation, note that when the part is rinsed after the passivation step, the act of passivation stops. So there will be no more passivation going on. And then you're only as clean as your last rinse. So, I mean, if you have the floor space to add another tank, another rinse is always encouraged. If you want to learn more about rinsing in particular, you can go on our website to some of our past presentations. Fernando Rueda gave one last August in 2020, and it's just why rinsing your parts is important. It goes into much more detail on why more rinses the better. Moving on to testing. So in particular, I'm going to be touching on the ASTM A967 spec. They have about 5 different test methods here listed that they approve. If you send passivated parts through any of these tests and they come back as a pass, then technically you are passing this ASTM spec. And that's important, especially if one of your customers is requiring one of these specs. In particular, practice B, I have a couple highlighted here. The high humidity test, essentially what that is a humidity chamber. 90 degrees Fahrenheit, 90% relative humidity. And if passivated parts can last 24 hours in that humidity chamber, in those conditions, without rusting, then technically they pass that test. Of course, to do that, you would need to have access to a humidity chamber. Not everybody does. So I have the copper sulfate test highlighted as well. Whatever chemical supplier you're using, they probably have their own version of this. And that's more of a handheld, easy way to where you can use it on the spot on your parts that have recently been passivated. And you're able to see whether or not it's passing on your own. You don't have to wait 24 hours and stick your parts into a humidity chamber. I'm going to conclude tonight by talking a little bit, going a little deeper into this actual ASTM A967 spec. I was talking about concentrations earlier as well. So in that example of a successful passivation process, it was a 50% concentration of a citric acid product, not actual citric acid. This ASTM calls for at least 4 to 10% citric acid in the passivation bath for the parameters to have your parameters inspect for the ASTM. And chemical suppliers know that, so they know. So essentially, at 50% concentration, there's going to be the citric acid content will be in between that range. Moving more to the right, the temperature. In order to stay in spec with the rest of your parameters, again, your passivation tank has to be between 60 and 71 degrees Celsius, and there has to be at least 4 minutes of exposure for your parts. Going down quickly to the nitric acid at the bottom, same concept. I would like to draw the attention to the percentages. It does require quite a bit more nitric acid content to be within spec for the ASTM A967. So yeah, between 20 and 25%. The 20% is the lowest possible in order to be in accordance with the spec. And also note the time that you have to have the parts in contact with this nitric acid product for at least 20 minutes to be in spec. So I believe that's all the time I have for tonight. I'd be happy to answer any questions that you all might have.
Thanks, Will. If you'd like to discuss this topic further, please contact your local Kaizen representative or send an email to tech@kaizen.com. And we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.